All right, this is pre-algebra lesson 4.4. Yes, Gigi? Yeah. Okay. Simplifying fractions. You've been doing this a long time. I mean, since you've been dealing with fractions, you've learned how to simplify them. This will be third, fourth grade, something like that. To simplify a fraction, well, we'll get to that. Let's just go right to this. If I have this 1/2, and I was to ask you, to give me an equivalent fraction, you all understand this. Let me show you this really quick. If I have a pi, and there's half the pi that's here, right? What is the difference between half a pi here like this, and then if I actually just take my knife and cut it in half right here like that, and make this, instead of being 1/2, it's 2/4. What's the difference between these two? Nothing. They're still the same amount of pi, right? Or if I went like this and made it into 4/8, what's the difference? I mean, how much, is there any difference in pi here? If I just take my knife out and start cutting it into, no, right? The amount of pi hasn't changed. So, what is an equivalent fraction to 1/2? What's an equivalent fraction to 1/2? Still equal to 1/2, but written a little bit different. How about 2/4? Is 2/4 equivalent to 1/2? Yeah. What about 4/8? Is that also equivalent to 1/2? What about 100, 200ths? Is that, yeah, right, 1,000,000, 2,000,000s, right? They're all equivalent, okay? How can you go from like 3/5? If I said, okay, how can you write 3 other equivalent fractions to this? What could you do? What would be one thing you could do?
You can multiply each of them.
Multiply each of the numbers by whatever, right? You realize that, right? I mean, I can multiply them both by 2, which would make this 6/10. Or I could, another really easy one, you ready for this, is to just simply multiply them both by 10. What do I do with that? 30/50ths. And then if I want to, I can multiply them by 100 and make it 300 500ths, right? That's the easiest way of making equivalent fractions, is to just start adding zeros, right? You're multiplying both the top and the bottom by the same number, and then they're equivalent. Okay, kind of easy. Writing a fraction in simplest form. Writing a fraction in simplest form means that you're going to reduce it. Okay, if I have 15/20ths, that is a legitimate fraction, obviously, but can it be reduced? Is this in simplest form? The answer is not in simplest form. It can be reduced. How do you know it can be reduced? What tells you that it can be reduced? Do you know what tells you? So what did we just learn yesterday? We learned how to use prime factorization, right? We learned how to use prime factorization. What's the answer, Sheena? They have a common factor other than 1, right? Because all numbers have a common factor of 1. So a common factor other than 1, whatever the greatest common factor is of the two numbers, is the number you're going to divide both the top and the bottom by. So here's the deal. I'm going to show you the long way here right now, really quick. Okay, ready? What is the prime factorization of 15? No. What is the prime factorization of 15? 3 and 5, right? So then it goes, so 15 is 3 and 5. So 15 is 3 and 5. You're not going to be expected to do this every time. What is the prime factorization of 20? 2 and 10 and 2 and 5, right? Which is 20 would be 2 times, so not 3 and 5, it's 3 times 5. And this is 2 times 2 times 4. Not 4, 5, right? 2 times 2 times 5. What are the common factors here? 5. That means the greatest common factor is 5. You could have figured that out, right? You all saw that the greatest common factor was 5, which means that I can divide both the top and the bottom by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. That's how you do it. Now, here's the deal. If I give you this again, if I gave you 15 25ths, you can look at that and know what is the greatest common factor of 15 and 25. 5, that's where you just divide by 5, divide by 5. Now I have another question. What if I have this? What if I have 40/88? Okay, 40/88. One thing that you can do to simplify this is you don't even need to know the greatest common factor. All you need to know is any common factor. Divide it by any common factor. What number is guaranteed to be divisible here? You could, 2, right? I agree, you could do 8. In fact, 8 is the greatest common factor. But if we did that, it would be divided by 8, divided by 8. That would be 5/11. Okay, so here's the deal. Let's go back here. Let's do this. Let's go back to 40 over 88. And let's divide the top and the bottom by 2. What does that give us? 20 44ths. Is this done? Can that be simplified more? No. You can also divide that by 2 again. Divide by 2, divide by 2. That gives us 10 22nds. Is that done yet? No. Divide by 2, divide by 2. 5/11ths. Oh, there we are again. 5/11ths. We're still there. Does that make sense?
Yep.
So the quickest and easiest way is if you do know the greatest common factor, to divide it by the greatest common factor. It saves you a lot of steps. But if you're looking at a big number and you're not sure, okay, if you see they're both even, divide it by 2. Agreed? Does that make sense? Anyway, you guys try and do one of these right now. Let's try 28 35ths. Simplify that for me right now. All right, you should be done. What is a factor of 28 and 35? 7. Divide this by 7. Divide this by 7. That is 4/5. Did you get 4/5?
Yeah.
Did you all get 4/5?
I didn't finish.
Oh, did you get 4/5? Okay. That is the 3rd grade, 4th grade stuff. Now we get into pre-algebra. This is the 7th grade stuff. When they say, okay, I want you to simplify this. Now here's the deal. I need to explain something to you. I'm going to show you why you're allowed to do what we're allowed to do. I'm going to show you something else. Okay, this is what it looks like. Let's go back to this. Let's go back to 40 88ths. Okay, I'm going to write this over here. 40 88ths. I'm going to show you another way of doing this. What is the prime factorization of 40? Let's do that. 40, which is, that would be 2 and 20, 2 and 10, 2 and 5, right? So the prime factorization of 40 is 2 times 2 times 2 times 5. Agreed? Okay. What's the prime factorization of 88? Well, it goes 8 and 11. That's prime. And then it goes 2 times 4. And then 2 times 2. Okay, so it goes 2 times 2 times 2 times 11. Now, notice this. What if I was to break this up? I'm going to break this apart, and I'm going to go, what is the difference between this and 2 over 2 times 2 over 2 times 2 over 2 times 5 over 11? Now, notice this. What is 2 times 2 times 2 times 5? Isn't that what that is? Isn't that how you multiply fractions? You just multiply across? And the same thing here, multiply, multiply, multiply. Okay, so look. What's the difference between this and this then?
Nothing.
Nothing. Agreed? Okay, so then what is 2 over 2? 1. What is 2 over 2? 1. What is 2 over 2? 1. What is 1 times 5 over 11? 5 over 11. Right? So what I could do is this. I could actually get rid of these, right? That just becomes a 1. I can get rid of them. I can get rid of the pairs. I can get rid of the common ones because they're going to turn into 1 anyway, right? They're going to turn into 1 anyway. And 1 times anything is itself. So what did it turn out to be? 5/11ths. Isn't that another way of doing that very simply? Right? That's just another way of doing it. Okay, so then let me go back to this. X over xy. What's the difference between this and x over x times 1 over y? Not y. Y's on the bottom. 1 over y. First of all, what is x times 1? 1x, which is just x. And then what is x times y? xy. So you see that there's no difference between this and this. Agreed?
No.
Agreed? There's no difference? You've got to follow this. No difference. Therefore, what does x over x become? Anything over itself is 1. So then 1 times 1 over y is just, it's not just y. 1 times anything is itself, which is 1 over y. 1 over y is not y. It's 1 over y. There's my answer. Does that make sense? Y over 1 would be y. right? Oh my goodness gracious. You all better know the difference between 1/4 and 4 over 1. You better know the difference there, right?
Yes, yes.
So then there would be a big difference between y and 1 over y. There's a big difference, right? Okay. What about this then? So then what could I do? What would be the easy one? Before I even did all that, what could I do here? Is I could go like this. Just those x's can be gone.
Yep.
That leaves me with not just y. Y's on the bottom. If y's on the bottom, that leaves, what is that on top? A 1. That's 1 over y is the answer. Okay, let me give you another one. I'll give you a more difficult one. 3ab squared over 12ac. I'll do this one for you again. You're watching. First of all, I have numbers here. Can I reduce those numbers? Can I reduce the numbers 3 and 12? If I had this, if I have 3/12, can I reduce that?
Yes.
Of course. So then can I reduce 3 over 12 over here?
Yes.
Yes. What is 3 over 12?
1/4.
1/4. So we're going to put that down here. 1/4. They're done. Whoa. They're done. Okay. I have an a over an a. What does an a over an a turn into? That turns into a 1, which means that I get to do what? Just cross them out. They're done. Right? They're just gone. I have how many b's on top? 2. I have b squared up here, so it's b times b. And then I have, and can that be reduced with anything? No. So then that leaves me with just b squared up here, okay? And then I have a c on the bottom. Can that be reduced with anything? No. Now here's the deal. Do I leave this 1 right here? Do you ever put a 1 in front of a variable? No. Therefore that 1 is gone. So my answer would be b squared over 4c. Does that make sense? That's how you reduce variables. Okay? Let me give you one. I'm going to give you one. 2mn over 6m. I want you to reduce that for me. Simplify it, they would say. Or write in simplest form. Okay. The thing to do in this situation would be to write them all out. It's just to go, okay, this is 2 times m, and I won't do a dot. 2 times m times n over 6 times m. What you can do here is this. You realize that m over m is a 1. And a 1 over a 1 is just 1. It's just not going to change anything, right? So they're gone. 2 over 6, can I reduce that?
Yes.
Yeah, that becomes 1/3. So it's 1 over 3, and then the m's are gone. That leaves me with an n there, and that's it. Now, is that the answer? No. What's the problem with it? There's a 1 in front of the variable. That's no good. The answer is n over 3. N over 3 is the answer. Yes.
I didn't know, like, if you were supposed to put the n like, on the top or the bottom.
Now listen. The n's on the top right now, right? It started out, isn't the n on top? Isn't the n on top here? So then it doesn't move. You don't just decide to move it. It doesn't just jump around. Right? Did you get it right?
Does it have, like, it has to look like that?
It needs to be n over 3 is the answer.
Okay.
Did you get that?
Yeah.
Good. No, let's try this one then. Here's a good one. 24x squared y over 8xy. Okay, try that. So you're watching now. Here's the deal. Listen. Take the numbers first. Always do the numbers first. What is 24 over 8? Can I reduce that? That becomes 3 over 1. For now, we'll write the 1. Does that make sense? For now, we'll write the 1. The next thing we do is this. You look at this and I say, how many x's are on top? 2. And how many are on the bottom? 1. When I eliminate what I can eliminate, what is left? 1. Just 1x where? On the top, right? There's 1x on the top. Because if I write it out, it would go 24 times x times y over 8 times x times y. Those are gone. That leaves me with what? 1x on the top. Okay. And then when I eliminate the y's, what does that leave me with? Nothing, right? They're gone. 1s. Doesn't mean anything. So then 3x over 1. Do I leave it like that? No. It should be just 3x. How many of you got 3x? No, Brad? What'd you get?
I got 3x over 1.
Okay, so you got it right. You just didn't write it correctly. What did you get, Gigi? Okay. Oh, yeah. Here's the hardest one on the page. Here we go. Okay. All right, here we go. If you can get this one, then this, like I said, there's a hardest one on the page. If you need to start, you can write it out the long way, which would be, you could go 2 times 3 times m times m times n times n. You could do that over 3 times 3, and this will work, times m times n times n. Okay, and then you start crossing out what you can. Those 3's are gone. Those m's are gone. Those n's are gone. Those n's are gone. What's that leave me with? 2m over 3. Right? You see, that's the answer. Right? Right? Bradley, you with me? That's the answer. That's the long way. I don't think you need to do that. What you can do is this. It's this. Listen, as long as you can do that in your head, you can go like this. Go, okay, I have 6 over 9. That reduces to 2/3. Okay? And then I have 2 m's on top and 1 m on the bottom. When I reduce this, what's that leave me with? An m on the top. And then when I go, okay, the 2 n's on top and the 2 n's on the bottom, they're gone. Oh, there it is. Do you see what I'm saying? But it's the same concept as writing it all out and then eliminating. Writing it all out meaning using prime factorization. Eliminating them. Anyway, you can do it this way. How many of you got that? 2m over 3? No, Gigi?
I did 2 over 3.
Now, why would you, listen, this is very important. Why do you have, when we have this here, there's 2 m's on top and 1 on the bottom. When you eliminate them, what does that leave me with? Where? The m is on the top. Got to do that, right? Just pay attention to where that's at. Okay, I'll give you one hard one. Really nasty. Here we go. Of course you can get it wrong. Would you like to have $1 million, or would you like to have 1 over $1 million? Well, this one's worth $1 million, and this is worth one. It's not even worth a penny. You understand that, right?
1
millionth of a dollar, which is like,
1 millionth of a penny.
yeah, it's like 10,000th of a penny.
Oh my God.
So are they the same? Are they the same? Are these the same? No, there's no comparison here, right? So be careful with that. Here's my question. Here we go. Oh, I'm going to give you one little tricky one. They don't do it yet. I'm going to do it for you anyway. Okay, here we go. Negative 50. Here we go. I want you to do it. Okay, here we go. Big ugly thing. Numbers first, right? Numerals first. What is negative 50 over 25? What is a negative 50 divided by 25? Negative 2. On the top, right? Because there's a big difference between 2 and negative 2. Right? Between negative 2 and then 1 over negative 2. Well, they're totally different. So, okay, negative 2 on the top. We'll put a 1 down here for now, right? That's how you reduce it. What do I have on top here with these x's? What's on top? 2 x's on top and 4 on the bottom, right? There's 2 on the top and 4 on the bottom. When I reduce them, if I wrote them all out, it would be x times x over x times x times x, right? And you go, well, okay, okay, you could do that. Do you need to? How many are there when I reduce them? What do I have left? I have 2 x's on the bottom, right? I'm going to eliminate 2 sets. And there's going to be none on the top and 2 on the bottom. X squared on the bottom, right? Are you up here? I want you up here. Even now, I want you up here. With the y's, what do I have? How many y's on the top? 1 y on the top. How many on the bottom? 9. When I eliminate them, what am I going to have left? 8 y's where? On the bottom. Right? And then here I have 5 z's on the top and 1 on the bottom. When I eliminate them, that's going to leave me with 4 z's on the top, right? Is this done perfectly?
No.
Almost. Now, there it is, perfect. Negative 2, z to the 4th, x squared, y to the 8th. How many of you got that? No? Brett, what happened?
No idea.
Do-
I have no idea what happened.
So, well, I don't care at all. Did you follow this? Did this make sense? Because on your homework tonight, if you can't do this, then you can't do the homework.
Yeah.
Okay. What did you do wrong?
I don't know.
What answer did you get?
I don't really want to say it because I know.
Just say it. I know it's wrong, but I need to know so I can see what you did wrong so that I can explain. What'd you get?
I don't. Can I just show you?
All right. I think you guys can do this. Page 194. Whoa. Page 194. 1 through 40. Even.